simplifying like terms. Okay? This is question 3 on the first page that we're dealing with. We have to figure out which of these terms are like terms. So, a term in each equation is separated by a plus or minus sign, also known as positive and negative terms. Okay? So, we have 1, 2, 3, 4, 5, 6, 7 different terms in this equation. Okay? We have to figure out which one of them are like terms. We're going to look at terms that are connected to variables, and the variables will be any symbol that is not a number. So these look like A represents some unknown number. This will be our variable. Does anyone know what the number in front of a variable is called? Starts with a C. That's all.
Component?
Close. Co-something. Coefficient. That's right. So this term, this value in front of a variable is called the coefficient. So when we're combining our like terms, we're going to be adding and subtracting those coefficients. Now to figure out what is a like term, we have to look at the exponent of a variable. Okay? So when we look at this first one, we have 5a squared minus 6a. Are these exponents the same? So these two terms aren't like terms. Now what power is this a technically to?
1.
That's right. It's technically to the number 1 there. So what would be a like term of 5a squared, Seth? That's right, 7. We have 7a squared, so I'm going to highlight both of them. This is positive 5a squared and positive 7a squared. Okay, so those two are going to be like terms. Let's work with our next one, negative 6a to the power of 1. What would be a like term of those?
3a.
Positive 3a and positive 8a. Make sure you guys recognize that the operation in front of the term tells us if it's positive or negative. So this is negative 6a, this is positive 3a, and positive 8a. And finally, do I have any other like terms? What are they? All right, negative 2 and 7, these are constant terms, okay? And these are like terms, so we can collect those. What I'm going to do is I'm going to reorganize it and put them all beside each other so it's a little easier for us to understand. We have 5a squared plus 7a squared, okay? So those are the two that we've highlighted in yellow. We have negative 6a plus 3a plus 8a. Those are the ones we highlighted in green. And then we have negative 2 plus 7. So I've put them all beside each other to make it a little easier for us when we actually go to combine the like terms. Okay? So let's work on each pairing. Now, because I have 3 sets of like terms, how many terms am I going to have at the end? Anyone know?
3.
Yeah. All of these sets are going to combine to just one term. So we'll have we'll have 3 terms in the end. 5a squared plus 7a squared. Well, all we have to do is add the coefficients. So what is 5 and 7? 12. So we have 12a squared. Then we have 3 terms here. Negative 6a plus 3. What will that give us?
5.
Negative 3 and then plus 8? 5. That's right. So we're going to have plus 5a. And then negative 2 plus 7? Plus 5. And that's it. We'll highlight to show you what each of them combined into. So all of our yellow terms combine to 12a. All of our green terms combine to be plus 5a. And all of our blue terms combine to be positive 5. But that's it. That would be our final answer. And I'll write it without the highlighting. This would be our final answer to question number 3. Okay? All right, here's our second question. We have 1, 2, 3, 4, 5 terms. And we want to simplify this by getting like terms together. Okay? Like I said before, we have to make sure our exponents are all to the same value. Now, technically, I have 3 numbers beside each other. This would mean 4 times A times B. So this is all one term. When we multiply terms together, we just consider it one term. We have to make sure that since we have 2 exponents attached to a coefficient, we have to make sure that both the exponents have the same, both the variables have the same exponents as any other like term. So, for example, we have 4ab minus 6ab. Would these be considered like terms?
Yes.
Why? The variables are the same. What about the exponents? Yeah, they're both to the power of 1, right? So we know that those two are going to be like terms. Are there any other numbers that would be like terms with these two? No, that's right. Everything else is different. So let's look at the next one. 3a squared b. Would 4ab squared be the like term? Why not?
Exponents are different.
The exponents are different. Our a's to the power of 2 are b's to the power of 1. In this one, our a's to the power of 1. That's different. And our b's to the power of 2, which is different. So those two cannot be like terms. Even though there's a squared there, you have to make sure each variable has the exact same exponent. Are there any like terms to 3a squared b? Which one? That's right. We have 5, positive 5 a squared b. Our variables are same. And 4a b squared? It's the only one like that. Now, instead of putting them all together, I'm going to see if you guys are able to do this. We're just going to think about them. Without actually rearranging the equation, we're going to try to get our 3 answers. Okay? So, 4ab minus 6ab. All right? So we have negative 2ab. Now, instead of putting these together, I have 3a squared b plus 5a squared b. That's right. We just add the coefficients. So we have 8. And the variables stay the same. A squared b. And what happens with that? Stays the exact same, 4a squared. So we'll highlight this. The questions look difficult to start, but as soon as you organize them, guys, they are relatively simple to get through. Okay?